So last class we talked about parts of arguments, namely propositions and conclusions. We also discussed how propositions are supposed to be different from other types of sentences. We talked about how to find arguments based on their premises or on their conclusions. We talked about the two rules of good arguments, and then you tried to find hidden premises in arguments. And you did a good job. This class we're going to talk about inductive versus deductive arguments, and then we're going to discuss three forms of argument that are very similar but are importantly different. And then we're going to discuss some fallacies. So you might be familiar with this character, the character of Sherlock Holmes. The character of Sherlock Holmes is famously associated with a line, quote about deduction. I think it goes something like, "Deduction, my dear Watson." And the idea behind this quote is that Sherlock Holmes is reasoning about some sort of mystery, and he's reasoning in a way that's supposed to look like the deductive arguments we've been looking at. But what you'll actually find is that many of the instances in which Sherlock Holmes is reasoning and calling it deduction, they're actually instances of induction, not deduction. So there seems to be some confusion about what actually counts as deduction, so let's go over the difference. Here are two arguments. You might remember my favorite argument. Everyone with the initials NAB is perfect. I have the initials NAB, therefore I'm perfect. Here's a slightly different version of that argument. Everyone with the initials NAB has been perfect. I have the initials NAB, therefore I'm perfect. So you might wonder, how do these arguments relate differently to their conclusions? And the key, as you may have noticed, first of all, is that the second argument has this past tense bit in the first premise. It's not making a claim about everyone with the initials NAB full stop. It's just making a claim about everyone who has had initials NAB in the past. And so that changes how that premise can relate to the conclusion. So the first argument makes it impossible for its conclusion to be false, because that's a deductive argument. And the second argument makes it just less probable that its conclusion is false. So a good inductive argument makes it less probable for its conclusion to be false. Why? Well, you already know. It's the two rules of good arguments. So here's an example of an inductive argument. Delilah learned logic quickly. Computer programming is very similar to logic, so Delilah learned computer programming quickly. Here's an implication. Because inductive arguments don't actually guarantee that their conclusion is true, or that they're not false, it's possible for conclusions of inductive arguments to be false, especially when we have more information, or if we're given more premises. So here's an example of that same argument about Delilah and logic and computer programming. But what happens when we add this premise? Delilah lived in the 1st century CE. Now obviously computer programming wasn't around in the 1st century CE, so it's just impossible that Delilah could have learned computer programming, let alone learned it quickly. So it looks like this conclusion turns out to be false, even though prior to that premise, we might have thought that the first two premises made it less probable that that conclusion was false. So the idea here is that inductive arguments are fallible. They make their conclusions more probable, or they make their conclusions less probable of being false. So now I want to talk about three argument forms. Two of them are good. One of them is not. But they're all very similar, so it'll be easy to confuse a good one for a bad one. Hence, the review. So here's a premise. If insert something where the green text is, if that thing is true, then some second thing is true. Second premise, that first thing is true. Therefore, that second thing is true. That's all pretty abstract, so let's give it an example. If roses have petals, then roses are flowers. Roses have petals, so roses are flowers. Seems pretty straightforward. But let's try another example. If ants have petals, then ants are flowers. Ants have petals, so ants are flowers. You might think, hey, ants aren't flowers. And so you might think there's something wrong with this argument. But do these premises support their conclusion? That argument is the same form of the last argument you looked at, and you thought that the last argument was a good argument. So this argument must be a good argument. It has the same form. At least it's a good argument insofar as the premises support their conclusion. You might think that the conclusion is false, and you might think that because the second premise is false. Ants have petals. The point here is that the form of this argument is such that its premises support its conclusion. Notice that I didn't say anything about whether the premises are true. So that's one form of argument, and it's a good form. Here's a very similar form of argument. People call it modus tollens. You don't need to worry about the names. I'm putting them there just so you can distinguish them somehow. The first premise is the same. If the first thing is true, then the second thing is true. The second premise is different, however. The second premise is now talking about the second thing. And the second premise is also being negated, meaning we're saying it's not true or it's false. And when we do that, we get a different conclusion. We get a conclusion about the first thing, namely, the first thing is not true. Now, again, that's pretty abstract, so let's put an example on this. If humans have petals, then humans are flowers. Humans aren't flowers, so humans don't have petals. So that's the same form of the argument, and it seems true, and the premises seem to support the conclusion, so good argument, right? Let's look at another example. If bicycles have petals, then bicycles are flowers. Bicycles are flowers, so bicycles don't have petals. Is this a good argument? Well, you might be thinking, look, bicycles do have petals. And this conclusion is saying that they don't, so there's something wrong with this argument. However, there's two things to note about that. The types of petals that bicycles have are a little different. They're actually spelled differently, so that would be P-E-D-A-L-S. But also, even if it was the case that bicycles did have petals, so even if it was the case that this conclusion is false, it could be that the conclusions do, or that the premises do support the conclusion. And this argument does have the form of the last argument, and you said you thought that that last argument was a good argument form, so this one's good. So even if it sounds strange to say that bicycles don't have pedals, this argument for that conclusion is a good one. So here's where things get tricky. I've given you two forms of argument. They were good forms of argument, but there's this other form of argument that looks a lot like these first two forms, but it's a bad form of argument. This is what it looks like. If something has petals, then it has flowers. Roses have flowers, so roses have petals. That might sound intuitively plausible. After all, you're familiar with roses. They have petals. You've seen them all over campus. You're familiar with roses, and you're pretty sure that roses are flowers, or that they have flowers. And it seems intuitively plausible that if something has petals, then it has flowers. So, what's wrong? Is this a good argument? It's not a good argument, and we'll try to explain with another example using premises and conclusions that aren't so plausible sounding. Here's another argument. If the Earth is flat, then horizons will seem flat. Horizons seem flat. So, the Earth is flat. This is a bad argument, and it might be more obvious to you now because you know the Earth is not flat. This form of fallacious argument is called affirming the consequent, where consequent means something like the thing that comes after, or we could call it the second thing, as we did earlier. So the fallacious argument here is, the form of it is such that it affirms the second part of the if-then premise. So it's affirming the fact that horizons seem flat. And that's the fallacy. If you affirm that second thing, it does not make the first thing true. Not deductively, anyway. We're going to be coming back to that when we discuss science. Just know for now that this form of argument is not a good form of argument, even though it looks a lot like modus ponens and or modus tonens, those first two argument forms I showed you. Okay, let's discuss fallacies. There are many ways to produce fallacious arguments, so many ways that we can kind of organize them into the fallacious arguments that have like a similar form. And when we organize fallacious arguments into similar forms, we might as well like give them a name, right? The such and such fallacy. So here's an example. We could call something the bias fallacy, and here's what the form of the bias fallacy, it goes like this. So-and-so is biased, therefore so-and-so is wrong. But as some of you already seem to be aware, so-and-so can be biased without being wrong. Namely, a biased person can be correct. So we can't just infer that someone is wrong simply from the one premise that they are biased. Hence the fallacy. Equivocation is another fallacy. Here's an example. Happiness is the meaning of life. The meaning of life is the condition that distinguishes animals and plants from inorganic matter. Therefore, happiness is the condition that distinguishes organic from inorganic matter. So how is this argument fallacious? Well, it seems to be taking two different definitions for, quote, the meaning of life, and treating them as the same thing. So the meaning of life, in one sense, is like this purpose or this value that we place on life. And the meaning of life in the second instance is like the thing that biologists care about. And if you treat those two things as one thing, then you get this strange conclusion. And that's why equivocation, that is, equivocating two different meanings, is a fallacy. So question begging is another fallacy. And you might hear the phrase, that begs the question. And you might think all that means is someone is raising a question. But pro tip, in philosophy, begging the question does not mean merely raising a question in philosophy. It means something more specific, so we should review that. Here's an example of begging the question. NAB News is less biased than the alternatives. I just watched their expose about how other news agencies are way more biased. So how is this argument fallacious? Well, the implied conclusion for this argument seems to be that first premise. NAB News is less biased than the alternatives. But it would seem strange to have the conclusion of your argument also appear as a premise in your argument. After all, if we thought the premise was true when it was just a premise, then we didn't need to argue for its conclusion. So begging the question is including your conclusion as a premise in your argument. Now recall back to last class where you guys were looking for hidden premises. Not all arguments make their premises transparent, and so you might find an argument where the premise doesn't appear in, the conclusion doesn't appear in the premises because it's hidden. And you might find that after looking at the argument, there is a hidden premise, and the hidden premise just is its conclusion, the conclusion of the argument. So, begging the question is to include your conclusion for your argument as a premise in your argument, whether it's hidden or not. So the argument from ignorance is another form of fallacious argument. Here are some examples. Vaccines, sure, they might help some people, but no one has proven that they will never cause harm, so I don't trust them. Look, it's just a theory. Scientists disprove their theories all the time. How can we be certain that they won't disprove this one? We can't. So don't believe the theory. So how are these arguments fallacious? Well, notice what they're doing. First, they're calling attention to the fact that something hasn't been proven, or that there's a lack of evidence. And then they're drawing a conclusion based on that. The mistake they seem to be making is what conclusion they're drawing from the fact that either there is no evidence or not conclusive evidence. If there is no evidence, we cannot conclude that something is true or false. So a lack of evidence does not give us the truth of something or the false of something. It gives us just ignorance. And if something has not been shown to be conclusively true, it doesn't follow that it is therefore conclusively false. Similarly, if something hasn't been shown to be conclusively false, that doesn't mean it's conclusively true. So the point here is you can appeal to ignorance, but you need to be very careful about what you infer from that ignorance. From ignorance, we don't get conclusive truth or false. We just get some form of agnostic conclusion or uncertainty. Ad hominem arguments. Here's an example. Polly Titchen claimed that the tax policy was bad for the economy, but Titchen is incompetent and untrustworthy, so obviously Polly Titchen's claim is false. How's this argument fallacious? Well, what is the argument doing? If you take a look at the argument, you see that someone is making a claim about taxes and the economy, and then someone is making a claim about a person, and then drawing an inference or a conclusion about a claim. So the fallacy here is in attacking the person rather than the argument, namely that second sentence. We can't conclude from that second sentence anything about an argument, because the second sentence is a claim about a person, not an argument. So when we attack a person and then try to use that attack to undermine that person's argument or conclusion, we've committed an ad hominem fallacy. Some of you might have realized that the bias fallacy is often an instance of an ad hominem fallacy. Here's a fallacy that didn't show up in the reading, but is probably worth mentioning. It's called the fallacy fallacy. Here's an example. Aha! We just showed how your argument is fallacious, so we refuted your conclusion. How is this argument fallacious? I mean, after all, if we showed that your argument is fallacious, then you're wrong, right? Well, not so fast. So, imagine the following. Is it possible to have a bad argument for a true conclusion? Here's an argument. Roses are red. Violets are blue. Therefore, the Earth orbits the sun. That's a horrible argument for a true conclusion. So just because we've shown that someone's argument is fallacious doesn't mean that we've refuted their conclusion. So the fallacy here is to think that finding a fallacy in an argument means that the conclusion must be false. So remember, there can be bad arguments for true conclusions.